The first electronic computer, electronic numerical integrator and calculator, was developed in 1947 at the University of Pennsylvania, USA. This machine had vacuum tubes as switching devices. Von Neumann introduced the concept of stored program by around the same time, and the first digital computer using program EDSAC, electronic today storage automatic calculator, was announced in 1949. Later, Remington Rand of the USA developed the first commercial computer, the UNIVAC, using this technology. These vacuum tube-based computers could perform computations in milliseconds. They were very large in size, consumed lots of power, and emitted too much of heat. They required to be housed in a large air-conditioned room. During this period, computer programming was mainly done in machine language. Assembly language was invented in early 50s. The concept of operating system was yet to develop. A big revolution in electronics took place in 1946 with the invention of transistors by Bardeen, Brattain, and Shockley. The transistors were highly reliable and easier to handle and maintain than the vacuum tube. They required much less power. These transistors replaced vacuum tubes in computers during this period. Transistor-based computers of this generation performed the same function with more accuracy and speed than the first generation computers. They were less expensive as well. Another technological breakthrough during this period was the invention of magnetic cores for storage. The magnetic cores were used to construct large random access memories. Commercial applications rapidly developed during this period and dominated computer use by the mid-1960s. Honeywell 400, IBM 7030, and Univac Lark are examples of computers of this generation. This period also witnessed development of high-level languages like Fortran and COBOL and operating systems. During this generation, silicon transistors replaced germanium transistors. Integrated circuits were developed by interconnecting transistors, resistors, and capacitors grown on a single chip of silicon. Integrated circuits were used in computers. They were small in size, less power-consuming, and less expensive than the previous switching technology. Small-scale integration, which had components in order of 10 on a chip, gave way to medium-scale integration with components in the order of 100 per chip. Advances in storage technologies resulted in creating large capacity magnetic disks and tapes and large magnetic cores plates, random access memory. IBM 360 or 370, CDC 6600, etc. are examples of computers of this period. On software front, higher level languages were improved. Fortran 4 and optimizing Fortran compilers were developed. Standardization of COBOL 68 was another major development during this period. The fourth generation computers were made using very large-scale integration technology. Tens of thousands of components were packed on a single chip, the size of a fingernail. It led to the development of microprocessor. The advent of microprocessor ushered in a PC revolution, bringing down the cost of machines and increasing the power of the machine manifold. Magnetic core memories were replaced by semiconductor memory. Another development during this period was the development and spread of computer networks and gradual evolution of the Internet. Personal computer operating systems were developed during this period. Availability of PC-DOS, MS-DOS, and AppMac operating system software made computers more user-friendly. Graphic user interface technology was exploited to offer more comfort to users. PCs became more affordable and widespread during this period. IBM PC, Apple II, VAX 9000, Cray, etc. are all examples of computer of this period. A significant development in software was the development of concurrent programming languages like ADA. Another notable development was the introduction of interactive graphic devices and language interfaces to graphic systems. During this generation, very large-scale integration technology gave way to ultra-large-scale integration that led to the development of microprocessor chip with several million electronic components on each. Powerful laptops, notebook PCs, and desktops were the other developments during this period. Advances in storage technologies such as microfloppies, CD-ROM, DVD, flash memory, etc. increased data storage capability of computers in the 5th generation. This period also witnessed the huge growth into internet usage, particularly the popularity of www and email. The 5th generation is essentially about a new superbreed of computers. The revolutionary parallel processing is being used in the new breed of computers in place of conventional von Neumann architecture. On the software front, effort is being directed at developing languages to cope with such generation of computers. Languages known as functional languages and object-oriented languages such as C++ have been developed during this generation. Development of more user-friendly operating systems like MS Windows and Linux-based software products are the other developments during this period. Computers can be categorized into three, that is, by the operating principle, purpose of use, and its size. By operating principles, it can be divided into three, that is, analog, digital, and hybrid. Analog computer measures the input rather than counting, while digital computer counts rather than measuring. Like, for instance, a calculator and diode. Diodes measure, calculators count. Hybrids, however, are a collection of both. It both counts and measures. For example, the blood pressure machine in hospitals. It both measures and counts. Next up, by purpose of use. There's two, general purpose and special purpose. General being generic, like those Dell desktops you see everywhere, while special being specifically used. For example, MRI scans in hospital. It's just specific for one job only. Next up, by its size. It's divided into four, that is, microcomputer, mini computer, mainframe, and supercomputer. Microcomputers being divided into two, that is, portable and desktop. To simplify, portable meaning laptop and desktops meaning PCs, while mini computers are tiny laptops, and mainframes are gigantic high-speed machines, just a little bit slower than supercomputer. Well, you want to build a PC, you have to know the essential PC component. For this, you'll need a PC, a keyboard, a monitor, and a storage device.